Hello toppers. So now we are going to start the topic Ampere circuital law. Let's move with the topic from the chapter Moving Charges and Magnetism. Ampere circuital law. The line integral of vector B dot vector dl taken over the entire closed path of induction in a given to a perpendicular plane is equals to mu naught times the total current enclosed in that particular path. So what is that? See, we have actually different kind of integral as we know. Like the first one is a line integral, which is integration of something which is a factor, that is a function. And here, if that will be line, so this will be dl. If surface, so that will be ds. And if volume, so that will be dv. So like for different kind of phenomena, we just want to take different kind of scenarios of integration. Similarly, here a line integral of a part of that. So the line integral of vector b dot vector dl. Okay, this actually given the entire closed path of the induction. That means this. So consider a long straight current carrying conductor emerging out of and perpendicular to that plane of a paper. The magnetic lines are in the form of concentric circles concerned on the wire, like this. Consider some closed path in the magnetic field around the conductor as shown in the figure. Path 1 and path 2 and 3 are general shape. dl is an elementary path of the path 1 of a radius r. Let I be the current. What we compute? We compute vector b dot vector dl for each element and sum over all such contributions. For path 1, which is circular with the radius r, we get vector b dot vector dl is equals to b dl cos theta. We know whenever this dot symbol removed, so the angular component which comes in the nature, that is a cos theta. And if this will be a cross component, so the sin theta will be come in the nature. Now, what we will going to do, just put this value, the value of a B for a circular conductor, so that will be mu naught I by 2 pi r. The value of a length element, that is, I'm just taking r d theta. So, since vector B and vector D are parallel to each other, that means cos theta is equals to 1. So, dl by d theta gives the value of r. That means vector b dot vector dl is equals to mu naught times I divided by 2 pi r d theta. We just taken both side integration over there and get the values. Like vector b dot vector dl is equals to mu naught I divided by 2 pi. And when the angle is too small, we just take as a theta. Theta for C3. Integration of a b d dl is equals to comes like mu naught times I from Ampere's circuital law. So path second, b dot dl for arc AB is vector b dot vector dl is equals to mu naught times I divided by 2 pi theta for AB. The contribution of all the radial elements such as a BC are 0 because the B is a perpendicular to the segment of a DL of BC. For the entire path, we have these two factor comes in the nature. So how we can write? That we can write over there like a cos theta for AB plus cos theta for CD. And for the maximum values, this will becomes 2 pi. That means the finally which we will get 2 mu naught times I. For path 3, any DL component can be split into the radial and tangential component. So contribution will be depends only the angle subtensed by elements and the center, which comes integration of vector b dot vector dl is equals to mu naught by 2 pi times I, sum of the angles subtended by all these elements, mu naught by 2 pi I by, so this will becomes multiply with 2 pi. The final value which we will receive, that is a mu naught times I. Therefore, we can say Ampere's circuital law or Ampere's law is true for any path and in any magnetic field. It is mathematically written as an integration of a vector b dot vector dl is equals to mu naught times I enclosed, where I enclosed is the sum of all the currents flowing any the conductor enclosed the path. Now move ahead with some questions. Ampere's circuital law is equivalent to Gauss law, Biot-Savart law, Faraday's law, or Lenz's law. So the correct answer which we have, Biot-Savart law. If the integral of vector b dot vector dl around any closed path, that is called Amperean loop, is 0, then the net current through the Ampere loop must be 0. The net charge must be 0. B is equals to 0, that reason. Or Ampere's law does not hold good in this case. The correct answer for this question is the current through the Amperian loop must be 0. So this is all for today's class. I hope you understand the topic. So take care and thank you for watching this video.